Hi, in this video we're going to see what the significance of the discriminant is. And in the previous video we explored how you calculate what the discriminant is. Now in this video we're going to see what the significance is. So let's remind ourselves how we calculate the discriminant. If we have ax squared plus bx plus c equals 0, well, if we were trying to solve that quadratic equation, then we'd use the quadratic formula, wouldn't we? So we've explored the quadratic formula in previous skills. So it's this formula here. So that's the quadratic formula. Now let's focus on this expression under the square root. Can you see that if b squared minus 4ac was negatives, you'd end up square rooting a negative number. Now, you can't square root a negative number unless we consider imaginary numbers, which we're not going to do here. So you can't usually square root a negative number, and that means x would have no solutions. So let's write that down. If b squared minus 4ac was less than 0, then the original quadratic would have no real roots, we'd say. Roots, just another way of saying solutions. There's no real roots to the original quadratic equation up here, right? Now, what about if b squared minus 4ac was equal to 0? So b squared minus 4ac was equal to 0. Then remember what this plus or minus means. It just means we get two different solutions for x, whether we add the square root of b squared minus 4ac or we subtract the square root of b squared minus 4ac, we get different solutions for x. But if b squared minus 4ac was equal to 0, the square root of 0 is still 0. Whether we add the 0 or whether we subtract the 0 doesn't make a difference. Adding or 0 or subtracting 0 has no effect, and you get the same value for x. So basically, you'd end up with only one solution to this original quadratic equation. So what we say is we have equal roots. Now, it seems a bit weird to say equal roots. Why am I still saying roots? We get one solution, don't we? Why are we saying we get two solutions which are equal? And there's a kind of something called the fundamental law of algebra, but I'm not going to bore you with those details in this video. But basically, rather than saying we have one solution, we say we actually have two solutions, but they happen to be equal. We're going to get the same solution. So we say equal roots. We could say one distinct root as well. So one distinct root would mean the same thing. And what about if b squared minus 4ac was greater than 0? Then we have the square root of, say, I don't know, 9, doesn't really matter. And that will give you, square root of 9 would be 3. Whether you add 3 or subtract 3, that's going to make a difference to the solution. So you're going to get two different values of x. So in this case, we're going to say we have distinct raw roots, two distinct roots. So two distinct solutions. Now, in the previous video, we saw that the b squared minus 4ac, this thing here, we gave it a special name. So it's called the discriminant. So this expression here is known as the discriminant because it's discriminating between the different numbers of solutions of a quadratic, whether we have no solutions to the quadratic or whether we have just one distinct solution to the quadratic versus two distinct solutions. So let's apply it to this particular example here. By calculating discriminant, work out the number of real solutions to this equation here, x squared minus x plus 3 equals 0. So if we put a 1 here, now we need to calculate the discriminant, so let's do that. I'm going to do that down here. I'm just going to copy it down here. So we've got 1x squared minus 1x plus 3 equals 0. That's the quadratic we're trying to solve. So let's calculate the discriminant. Remember, the a is the coefficient of the x squared, so a is equal to 1. B is the coefficient of the x term, so this is the minus 1. And c is the constant term, the term without a variable in it, so that is 3. So always write out the a equals b equals c equals, and then we substitute it into the discriminant. So the discriminant is b squared minus 4ac, and that is equal to minus 1 squared. Whenever you have a negative number to a power, always put it in brackets. Subtract 4 times a times by c. And if we calculate that, we get 1 subtract 12, which is minus 11. Now, if we look at this information here. If discriminant is less than 0, we have no real roots. Now, this discriminant of minus 11 is negative, it's less than 0, so that means we have no real roots, which is basically saying that this equation here has no solutions. So what we'd write is we say this is less than 0, therefore no real roots. So you should compare your value, your discriminant, that you've calculated with 0. So we say it's less than 0 and then give a conclusion. It has no real roots. So discriminant was minus 11 and therefore the number of real solutions, 0. There's no solutions to this equation.